Welcome to my YouTube channel where I share with you my journey towards data science. Hello everyone, my name is Idalia, or like everybody calls me Nurse C. I am a nurse, like Florence Nightingale, kind of the 21st century, that loves data science, finance, and technology, and I want to share with you what I've learned so far, but also help others to see the potential of other technologies that we could use to improve our productivity, but also improve, our work and the things that we can achieve. So today I'm going to share with you the second assignment that I had on my bootcamp, doing some Python analysis, and this was about the JFK airport dataset that you have available on Kaggle, so you can download it and do this too. And my question was, should I fly from JFK airport or not, and based on the data that I had available. And the aim was to do some modeling regression, so we did some basics linear regression and AI modeling basically. So I also follows the same approach: problem to solution, get, explore data, and prepare data, and kind of shortlist the models that I want to use. So first I looked at the problems and solutions. So, our outcome variable was always taxi out. Like taxi out, what does that mean really? I didn't understand anything about operations of an airport actually. So if you work in the airport, feel free to comment below, teach me a little bit more about the operations of managing your airport and so many flights, and to make sure that they're on time, because I don't understand anything about it. So I had to do some dig around to see what really meant. So for me it was to understand, okay, what is taxi out? So from what I understood is kind of moving on the airport's taxiways from its gate to the runaway prior takeoffs. And this is important because it can increase fuel consumption of a plane, obviously in the costs, affects other flights, and impacts the operation, and actually increase costs to everyone. So that's why it's such an important variable, maybe for the JFK airports. I don't know. Please, if you understand anything about airports, comment below, tell me a little bit more about it, because I don't really know. So I wanted to understand the problem. So our problem was, we really wanted to do a little bit dig down about basic descriptives of flight operations to understand a little bit more, and maybe whether we could predict which variables really affect the taxi out outcome, and really explain the kind of delay on increased taxi out times. So we did some basic descriptive statistics and linear regression models, such as the linear regression, random forest, lasso regression, ridge regression, calculate errors. So in terms of get the data and explore it, what we've done was to try, import all the libraries necessary, import the dataset. You can use this dataset, go on Kaggle, you just download it and do exactly what I did. You can download also mine or other people's, Python notebooks and actually work with them. And then I did some basic descriptive statistics. So like here, I used ChatGPT to actually ask me, can you help me get some interesting questions that I can ask the data, and what kind of things can I look into? So that's what is done, because obviously, we don't have too much time to do this. We only had like 2 or 3 days, and after the end of the classes, so you can see that it's very hands-on and very practical, but also very tiring. Then we did so we looked at the data structure. So we had 22 variables with different types of data frames. So we had intergens, we had objects, we had floats. Then we looked at the structure, as you can see here. Then we kind of described the data and tried to understand kind of main things. So we could see that, for example, the wind speed had a minimum of 12. The mean taxi out was 20 minutes, but varied between 5 to 40 minutes. We could see that humidity in New York airport was actually on average, but had high humidity levels of about 74%. And the temperatures were average of 5 degrees, and this was because the data was between November and December, so actually only reflects a little bit more about these dates. Then we did a little bit more box plot to try and understand if there were many outliers or not. So we could see, for example, that the temperature varied between a certain period, but there were a few outliers in the data, such as the wind speed as well, and some taxi out. So the taxi out varied between a few minutes to about 40 minutes, as I said before, but as you can see, there are a few outliers within the data that we can see here. Then we looked, for example, what is the average departure delay for flights in this dataset, and we can see that the mean delay is about 6 minutes, but you can see that the median and mean are quite different, so perhaps we don't have a normal distribution of data, so we should use the median, which is more representative, which is about -3 minutes. Why -3 minutes? So does that mean that perhaps the data, actually majority of the flights actually have less, are actually earlier on time rather than late? Maybe perhaps that's the case. I don't know, if you're an expert in flight operations, please let me know down below why we have such negative numbers, and if that my assumptions are correct. And then the minimum was -22, and then the maximum was like 1,276 minutes, but majority, the 75% of the flights had a departure delay of less than 2 minutes. So actually, if you fly from JFK, 75% of times you hopefully have a departure delay that less than 2 minutes, so that's great. But maybe because the cancellations don't count here, only counts those that depart. Interesting, right? So top 10 destinations. So if you actually want to go to Los Angeles, perhaps it's a good idea to go from the New York airport, because there's lots of flights there, and also to San Francisco and Boston. It was quite interesting that there are so many to Los Angeles, right? Almost 3,000 during a small period of time, right? Then we asked, how does the distance travel by flight impact season elapsed time? So you can see that we have a kind of a linear way. So as more the travel distance increases, so does the elapsed time. Then we looked if there were any correlations between the temperature and the number of flight delays. Not really, doesn't it? There's a few outliers, but nothing really exceptional. Then we looked at other correlations. I mean, you can't see it here very well, but I would suggest, if you are interested, go and download my PowerPoint and you can see more. Then we looked at what's the average taxi out for the flights of the dataset. As I told you before, this was 5 minutes between almost 40. And then which day of the week has the highest number of flight delays? So day 6, but it was impossible to understand which day of the week referred to because there were no data set definitions. So if I were you, just be extremely careful on the data set. Don't assume anything, because sometimes the data set might be, I don't know, female and male. You always assume 0 male, 1 female, but it might not be the case all the time. So make sure that you really ask the right questions. Make sure that what you think it is actually what you think. So here it was actually impossible. I don't know. Then we prepare some data. So for example, to hand missing values, in the case of the category for available wind, we impute the missing values with the mode. And then we selected some performance measures such as the root mean square error and the average absolute deviation. So if we had too many outliers, perhaps we should look at the AME. And then we checked assumptions. So I just wanted to say that in this case, basically, don't forget that the data was from November 2019 to December, and obviously during that time we had COVID-19. So obviously, maybe the data is not very reflective of the data that we, of the flight operations that we have nowadays. And obviously that's a short period of time, so it doesn't count the summertime, the springtime. So you bear in mind all these kind of assumptions that you might take, and don't generalize for the rest of the year if you only have data for November and December, especially if it was impacted by a period such as COVID-19. Then we looked at our regression models. So this was with a linear regression. We got an R2 of 0.004, not that great. And then this was for another linear regression, so I've used other predictive variables. You can't see it here because by some reason the PowerPoint had few animations and it doesn't show it here by using the software, so maybe that's why you can't see them, but if you download my PowerPoint you can see them. Then we did some ridge regression. We had a R2 of 0.08, so not that great. And then we had a lasso regression, 0.30, so that was much better. So 30% of the variance might be answered by those variables. And and this was regression was terrible as well again. And then we had random forest, which had a R2 of 0.30% as well, where actually was the best one. So the conclusions were that the modeling results were limitative. Random forest was the best model, with 30% of the variation being of the taxi out being explained by the predictive variables that we used. So you can check on my PowerPoint which variables did I use. I don't know exactly now because I'm recording this like almost at the end of the bootcamp. This was actually the first project that I've done some modeling. So what I've concluded is that, let's see if I have some time still. So yeah, I should have started earlier and spend more time on the modeling. I only started the modeling like on Thursday night at 10 o'clock when I had to present on Friday afternoon. I really underestimated the time that this takes because, when I was in class, what they do is they present you this massive, great results of 96%, 94% all the time. And you kind of underestimate, this must be easy. You must be just plotting and this will be very easy. No. Completely the opposite. You have to be going around, then you might have problems with the data and data frames, and then you might have to do reshapes like I had to do, and sometimes you don't see anything like that in the class. You actually have to do it to see the immense problems that it might occur. And so next week what I should have done, and I did that actually, I started on Monday, not on Thursday. And if I had more time on this case, I should have classified timeout into perhaps different categories like delay, not delayed, to predictive delay occur instead of the time. And obviously I need to understand more time understanding results. I find it a little bit difficult to interpret it, studying pandas basically, also how do you create data frames and all those things. So I hope this is useful for you and you can see that what you can achieve with just a few weeks of a bootcamp. And if this was useful for you, please like and subscribe, share your comments, so that can help me to bring much more content to you. And I hope I can share with you my progress that throughout the months and throughout the years. And I hope you enjoy it too. Take care. Have a lovely rest of your